There are two types of garbage collection performance optimizations: weak references and generations. Weak references are a means of performance enhancement used to reduce the pressure placed on the managed heap by large objects. When a route points to an object, it's called a strong reference and cannot be collected because the application's code can reach the object. When an object has a weak reference to it, it basically means that if there is a memory requirement and the garbage collector runs, the object can be collected when the application later fails to access the object. On the other hand, to access a weakly referenced object, the application must obtain a strong reference. If the application obtains this strong reference before garbage collector collects the object, then the garbage collector cannot collect it. The managed heap contains two internal data structures whose sole purpose is to manage weak references: the short weak reference table and the long weak reference table. Weak references are two types: short weak reference and long weak reference. A short weak reference doesn't track resurrection. The object, which has a short weak reference to itself, is collected immediately without running its finalization method. A long weak reference tracks resurrection. The garbage collector collects object pointed by the long weak reference table only after determining that the object storage is reclaimable. If the object has a finalized method, the finalized method has been called and the object was not resurrected. These two tables simply contain pointers to objects allocated within the managed heap. Initially, both tables are empty. When you create a weak reference object, an object is not allocated from the managed heap. Instead, an empty slot in one of the weak reference table is allocated. Short weak references use the short weak reference table and long weak references use the long weak reference table. What happens when a garbage collection runs? The garbage collector builds a graph of all the reachable objects. In this diagram, the graph will include B, C, E, G objects. The garbage collector scans the short weak reference table. If a pointer in the table refers to an object that is not a part of a graph, then the pointer identifies an unreachable object and the slot in the short weak reference table is set to null. In this diagram, the object D is set to null since it is not a part of a graph. The garbage collector scans the finalization queue. If a pointer in the queue refers to an object that is not the part of the graph, then the pointer identifies an unreachable object. Then the pointer is moved from the finalization queue to reachable queue. At this point, the object is added to the graph since the object now considered as reachable. In this diagram, the object A, D, F are not included in the graph. They are treated as reachable objects because they are part of the finalization queue. The garbage collector scans the long reference table. If a pointer in the table refers to an object that is not part of the graph, then the pointer identifies an unreachable object and the slot is set to null. Since both objects C and F are part of the graph, none of them are set to null in the long reference table. Generations. Since garbage collection cannot complete without stopping the entire program, they can cause arbitrarily long pauses at the arbitrary time during the execution program. Garbage collection pauses can also prevent program from responding to event quickly enough to satisfy the requirement of real-time systems. One feature of the garbage collector that exists purely to improve performance is called generations. The The generational garbage collector takes two facts that have been empirically observed in most programs in a variety of languages. The first one is newly created objects tend to have short lives. The second one is the older an object is, the longer it will survive. Generational collectors group objects by age and collect younger objects more often than older objects. When initialized, the managed heap contained no objects.